All right, today we're talking about architecting for clarity. We're going to break down how you can design systems that you can actually understand when things, inevitably go sideways in production. Let's kick things off with a scenario that might feel a little too real. Okay, just picture it. It's 3 a.m., your pager is screaming, the alerts are a sea of red, and production is down. It's like gut-wrenching moment every engineer absolutely dreads. A situation we've all been in, or probably will be at some point. Sure, the alerts tell you what's broken. The API is slow, the database is throwing errors, but the really critical question, the one that's going to decide how the next few hours of your life are going to go, is this one. Do you have any idea why? Or are you just staring into a complete black box? A system that's running, but it's totally opaque, you know it's failing, but it's hiding all its secrets, and your only real option is to just start guessing? And that right there, that's the exact problem we're going to solve today.
So the solution isn't just about adding more dashboards. It's a fundamental shift in how we approach our systems. It's a concept called observability, and it's all about being able to ask new, totally unexpected questions of your system while it's live.
So what is it really? Here's the key definition you gotta remember. Observability is the ability to ask new questions of your system, questions you didn't even think of when you wrote it, and get the answer without having to ship new code. And that last part is absolutely crucial. No more redeploys just to understand what's going on.
And you have to realize this is a huge distinction from traditional monitoring. Monitoring is all about asking questions you already know you need to ask, like what's the CPU usage? It tracks the known unknowns. Observability, though, is for the unknown unknowns, those bizarre, wild failures in complex systems that you could never possibly predict. It's a shift from just tracking system health to enabling deep, interactive debugging. And this brings us right to the main point of this whole explainer. Observability is not some tool you just bolt on later. It's not something the ops team adds in. No, it is a core architectural property. You have to design it in from day one. So how do we actually do that? How do we build this property right into our architecture? Well, it all rests on 3 foundational pillars that have to work together to give us that clarity we need when everything's on fire. And those pillars are structured logs, meaningful metrics, and distributed tracing. When you design these 3 correctly, they give you all the raw data you need to ask those new, complex questions about your system's real behavior.
Let's start with logs. A simple string of text just doesn't work when you have millions of them. Structured logs, think JSON, are machine readable. They turn logging from just, writing a diary into creating an actual database of events. So the most crucial point here is this. Your log structure is a schema design decision, just like your database. And every single log event must have that core context, like the service name and a request ID.
Okay, next up, metrics. Look, CPU and memory usage are fine, but they don't tell you if your users are happy. Meaningful metrics are designed around the user experience and the specific behaviors of your service. We're talking request latency, error rates per endpoint, or items processed per second. These are your SLIs, the things that tell you if you're actually meeting your SLO. And finally, we've got distributed tracing. In today's microservice world, a single user request can bounce between dozens of services. Tracing is what stitches that entire journey together. And this is where the architectural part becomes so clear. You have to deliberately design your services to propagate that trace context from one hop to the next. It just doesn't happen by magic.
Now, having these 3 pillars is great, but the real power isn't in isolation. It's unlocked when you can connect them, when you can pivot seamlessly from one to the other to tell a complete story.
So how do you do that?
With correlation. A single, unique ID, a request ID, or a trace ID, it has to be present in every log, every metric, and every traceban related to a single request. This is the thread that ties everything together, and you have to design your APIs and even your async message queues to pass this context along relentlessly.
This is really the aha moment. Correlation is where observability just clicks. Imagine you see a spike in your checkout_API_error rate metric. With a correlation ID, you can instantly pivot to see the exact traces for all the failed checkouts during that spike. You notice they're all slow at the payment service step. You click on one of those slow steps, and bam, you're looking at the structured logs from the payment service for that exact request, which tell you it's timing out trying to reach a third-party processor. And that's it. That's how you go from guessing to knowing in minutes. So, let's see how this all plays out in the real world.
We'll compare two systems, one designed as a black box and one designed from day one to be observable. The initial engineering effort is only slightly different, but their fates in production are worlds apart. Let's just compare these two designs directly. The black box system, it relies on minimal, unstructured logs and just basic infrastructure metrics, with no real tracing. The outcome is pretty predictable. Guesswork, finger pointing, and frantic redeploys just to add more logging. Now, in contrast, the observable design has structured logs, user-centric metrics, and end-to-end tracing built right in. The outcome there? Fast, data-driven root cause analysis. It is literally the difference between a 3-hour outage and a 3-minute investigation. But architecting for observability isn't just about what you should do. It's also about knowing what to avoid. So let's look at a few common anti-patterns that can undermine even the best intentions. Here are some of the classic anti-patterns. Logging everything just in case just creates a ton of noise and costs a fortune. Inconsistent naming across teams makes correlation basically impossible. Missing context in async flows breaks your traces. But the biggest one? Treating this as an ops problem. The developers who write the code have to own its observability. It is an integral part of the feature itself. So as we wrap this up, I'm going to leave you with this one question to take back to your team. When you start designing your next feature, your next service, or your next platform, are you just designing it to work, or are you designing it to be understood? Because at 3 a.m., that's the only thing that's going to matter.